Hey everyone, we're going to look at number 3 in section 4.3. We're going to find all points C satisfying the conclusion of the MVT, which is the mean value theorem, for the function f of x equals 7e to the negative 5x plus 3 on this interval. Again, your numbers might be slightly different here, but very similar problem. So MVT, or mean value theorem, reminding you of that. It's if the function f is continuous on a closed interval from a to b, including the a and b, and differentiable on the open interval from a to b, then there exists C such that f prime of C is f of b minus f of a over b minus a. And I would refer you to my lecture video. If you should have watched that, and I explain this whole process where the importance of this, and graphically show you what it represents as well. So it's a very important theorem that we use in proofs of lots of other theorems in calculus. And in this case here, we're simply going to find the point C satisfying basically this equation. So I've got to get this equation up and then solve the equation. Okay, so first, this side is just a computation, right? Where we're using this function, and this is the value of A, and this is the value of B. So f of a would be f of 0. If I plug in 0 into this function for x, I get 7e to the 0, right? Negative 5 times 0 is 0, plus 3. E to the 0 is 1, so this is 7 plus 3, 10. When I plug in 3 into the function, I get 7e to the negative 5 times 3 is negative 15 plus 3. So can't really simplify that at all. And then f of b minus f of a over b minus a. So f of b is this part. F of a is 10, so minus 10, over b, which is 3, minus a, which is 0. So I get 3 down here. 3 plus a negative 10 is negative 7. Now I'm going to go ahead and factor out that 7. Can't really simplify. 7 and 3 have no common factor. So here's my final result. It's kind of messy. Got 7 times e to the negative 15th power minus 1 over 3. Now that's this side. What's f prime of C? Well, I have to take the derivative of this function. And so the derivative of this function, the 7 is a constant multiple pulled out. That derivative of e to the negative 5x is the chain rule, right? I've got a composition of functions. The outer function is e to the u, and the inner function is negative 5x. So the derivative of e to the u is e to the u. So e to the negative 5x times the derivative of the inner function. What's the derivative of negative 5x? Negative 5. Right, so I get e to the negative 5x times the negative 5. What's the derivative of 3? It's a constant, and derivative is 0. So I got 7 times negative 5, or negative 35, e to the negative 5x. There's my derivative. So we now can plug into our equation, right? What's f prime of C going to be? I just replace x here with C, equals f of b minus f of a over b minus a, which we calculated to be this thing, which is really 7/3 times this, 7/3 times e to the negative 15th times a negative 1. So the way to solve now for C is, first of all, divide by negative 35ths, or multiply by negative 1 over 35, right? So that will give us coefficient of 1 over here. And I can do some simplifying. 7 goes into 35 5 times. And so I have negative 1/5 times 1/3, which is negative 1/15th times this, or negative all this stuff divided by 15. Okay, because I have this stuff divided by negative 15 will be a negative number, right, over this stuff. And then how do I solve for C now? Well, I need to take what? The natural log of both sides, right? Oops. A natural log of all this stuff here. Right, and what happens here? Natural log of e to the negative 5c is just negative 5c by the inverse property of the general exponential function and the general logarithmic function. Okay, and then how do I solve for c? Divide by negative 5. So I've got the natural log of all this stuff divided by negative 5. Now I'm going to plug this into my calculator. To make it a little bit easier, I'll go ahead and distribute the negative 1 up top. So this will become negative e to the negative 15th plus 1, all divided by 15. And you can see I've done that in my calculator here. So I've got up top natural log, and then I've got parentheses around the natural log, and then parentheses around the numerator part. Why don't I make sure I do this negative e to the negative 15 power minus a negative 1 is plus 1. All right, so there's the numerator divided by 15. It's just one way to make it a little bit easier in the calculator. So all of that, right, the natural log of all this stuff divided all by the negative 5. Make sure you're using the little negative button for negative 5 and not subtraction key. You'll get an error otherwise. So make sure that you're good with that. We get this number, and they wanted us to round it to the third decimal place. So we would round that 1 up to a 2 because the next number is 5 or higher. So 0.542. Important to note that that is in the interval from 0 to 3, as we're guaranteed to have at least one value. It turns out we just have that one value in this interval. Okay, so kind of a crazy problem in terms of solving. You've got to remember how to solve exponential, log equations, trig equations. They're going to come up in this in chapter 4 as we go through applying the derivative. So hopefully this is helpful. Let me know if you have any questions.